Welcome to Strength in Concrete, the podcast presented by the Post-Tensioning Institute, recognized as the leading authority in advancing the post-tensioning industry. In this episode, our host Tim Christle, the Executive Vice President of PTI, is joined by Bob Sward, Vice President of Structural Technologies, to explore the evolution of post-tensioned concrete bridges over the past 60-plus years. Together, they discuss key benefits and applications for post-tension bridges and advancements in design, construction, and technology that have greatly enhanced these bridges during this evolution. Listeners can anticipate an in-depth conversation that also busts some of the myths in the industry which aren't applicable to today's modern PT bridges. We'll also hear some initial thoughts on newly emerging technologies which strive to continuously improve the long-term durability, resilience, and sustainability of post-tensioned concrete bridges. Now, as they bring their expertise and insights to the forefront, join us in discovering how the industry continues to innovate and build stronger infrastructure for generations to come.
Welcome, everybody, to our podcast series. This is our first episode in this series where we're talking about post-tension concrete bridges. We're looking forward to this podcast series to talk to a variety of our experts, PTI members, and those that are in the industry with, again, specific expertise in the PT concrete bridge world. Today, we're going to be talking to Bob Sward. Glad to have him with us here. Bob is with Structural Technologies. So very glad to have Bob with us today to talk about a couple different topics and kick off this episode. So Bob, welcome to the podcast. I wanted to start things with kind of a kickoff of a general discussion, which really starts at the root of when an owner, developer, whoever it may be, is deciding to do a concrete bridge versus a steel bridge versus other alternatives and looking at different span situations. Just kind of kick off an initial discussion about what are some of the key reasons why a PT concrete bridge, and again, specifically post-tension concrete bridge, why it would be beneficial and ideal for an owner's bridge solution. And of course, in general terms, I know we're probably talking more about medium and long span situations, but maybe just initial touch on some of those key benefits of post-tension concrete bridges.
Thank you, Tim, for the introduction there and having a chance to talk to you. This is a topic that's a passion of mine. I've been involved with post-tension concrete bridges, all of my career since the mid 80s, and love talking about them. The first thing that jumps to my mind about benefit of post-tension concrete bridges is the ability to span greater distances with shallower members. There's also the durability aspect where we are pre-compressing the concrete with the post-tensioning to offset any tensions, so that's going to make for a much more durable structure. And we all know that concrete is already a very durable building material, and when we can post-tension it and keep it in compression and minimize tension and cracking, we extend the service life and the durability of these types of structures. Post-tension structures that can either be precast or cast in place. You can do extremely long spans with cast in place segmental. I think there's a cast in place segmental bridge over the Canal River that spans, I think, almost 800 feet. Was done cast in place with travelers. You can also do precast spans that are very long. The one job that comes to my mind is the St. Croix River Crossing, which is precast segmental bridge, but it's also extra dosed with stay cables. From a durability perspective, I think the industry has come a long, long way since I started back in the 80s, both in our understanding of the materials and how they perform, both post-tensioning systems and the concrete. From the design perspective, material selection perspective, the training and knowledge of the crews and the equipment we do, we see a huge, huge improvement in the overall durability and quality of cast in place and precast post-tension bridges. We already know that, and we've seen it from highway surveys, that post-tension concrete bridges perform very well over the long term. And that's one of the key benefits of post-tension concrete bridges is the long-term durability. And it's one thing that struck me as I was thinking about this. I knew we were going to be talking about it. Back in the 80s when we started, we bid jobs, and a lot of these more complex bridges would have two alternates, a steel alternate and a concrete alternate. And then whichever was the most economical was the one that was selected. So we were basically choosing bridges based on the first cost. And I think as we become more aware of our environment and the sustainability and not having to replace bridges, hopefully not having to replace bridges as often, we're finding out that concrete bridges actually, typically have a longer service life and a lower maintenance cost. So they become, when you look at the long-term cost of these structures, they're actually less expensive than other options that are out there. So I think that's another a key benefit. If you take a look at the overall life cycle of these structures in your selection, I think that you'll find that the post-tension concrete bridges are one of the better solutions that are available out there.
I know there's also certainly scenarios, obviously, for bridges where they're going to span, they might be spanning a city street, they might be spanning a federal highway, they may be over a waterway, anywhere from a large bay to a small river. And there's also environmentally sensitive territories where you really can't build something off the ground like you might be able to otherwise. And so maybe could you address some of those unique features that have to do with
Sure.
where the bridge is located, what it's spanning over top of in terms of keeping operations uninterrupted or keeping the environment protected, and how there are some post-tension concrete solutions that help accomplish that, whereas maybe other tactics won't.
Yeah, that's a good point, Tim. There's with post-tension concrete, particularly precast segmental construction, you can do top-down construction from the foundation up. We did a project in Tennessee where we built a bridge from the top down, including even putting in the foundations. We built a trestle out to minimize the amount of damage we did and destruction we did to the side of this mountain. We worked from a trestle that we built, and we drilled the foundation, set precast columns and post-tension them down, and then we built the precast segmental structure all from above. And it was a very small footprint on the environment when we did that. And I've seen it done that way before, working over railroads where you really don't want to have anything falling down on the tracks. So precast segmental works there. We've done cast in place segmental over railroads as well. So able to work from above without having to have a lot of shoring down below really provides a lot of flexibility on the type of structure.
And even though, like, stay cable bridges, the stays themselves aren't specifically pre-stressed concrete, post-tension concrete in and of itself, like the longitudinal sections are, maybe touch on, because we're, the PTI committee on stays and the fact that stays kind of belong in the post-tensioning universe, maybe talk a little bit about some of the amazing things we can accomplish for very, very long spans with stay cable technology.
Oh yeah, that technology's come a long way from where it was back in the 70s and 80s. The systems now are very robust, and the systems are very, I think we're making for very economical structures that can span, incredibly long distances here in the US. I think, 1,1700 feet spans, main spans, around the world, they go much further than that, over 2,000 feet, I believe in some cases, which is just an amazing span. These structures can either be steel, decks, edge girders and floor beams, or they can be concrete. There's a bridge in construction right now down in Corpus Christi where the bridge deck is precast segmental over the Corpus Christi, over the entrance to the harbor there. And the same with the Houston Ship Channel. Both decks are concrete stay cable bridges. And you can span the long distances and in a fairly economical solution for those long spans.
Good point. So kind of shifting as well, and you were touching on it earlier, because it is one of the key benefits, of course, the durability and overall sustainability of post-tension concrete, not only in other structures, but bridges specifically, because as we know, there's exterior environmental conditions, whether you're over top of a salt sea spray and over a waterway that's extremely corrosive environment, and or just a regular highway situation, or situation where any other environmental materials like chlorides and things, wetting and drying and thermal changes and things can have an impact on concrete. The one big issue with durability, which again, as you touched on, post-tension concrete is extremely durable, but there's this general myth that's been out there for a period of time about the nature of post-tension concrete bridges. Of course, they began way back in the day. And we're talking about stuff that goes back to the 1950s and 60s. And then there was a period of time in the 70s, 80s, and 90s where bridges were being built. And then, as anything else, there's an evolution all the way over the last 30 years up to today. And so, yeah, we've seen stories about things that maybe occurred with an in-place bridge that's 50, 60 years old, and that is what it is. But I want to touch on next and kind of bust the myth, if you will, on the idea that post-tension concrete bridges are somehow not durable in regards to their post-tensioning systems themselves. So we've got the concrete part, which obviously needs to be a durable material and done correctly, but then the PT systems, and we're talking, of course, about a series of things like multi-strand tendons or PT bar, and then the anchorages and the end caps and everything else. I want to kind of get into that conversation. That's really important to have people understand all the things that have changed over the last, especially 25, 30 years, but even as far back as 50 years, to greatly improve that technology, greatly improve the durability, so that today's post-tension concrete bridge is really nothing like your grandfather's post-tension concrete bridge.
Absolutely. You're absolutely right, Tim. What we were doing back in the 80s when I started, we thought we had it all figured out, but we've come to learn that, cement and water with an expansive admixture is not necessarily the best grout design for post-tension tendons. You can get a lot of bleed, which creates voids in the tendons. And there's been like you said, there's been a fair amount of negative press on PT structures because of these voids and some issues that happened because of those voids. In the industry, once we discovered that this was becoming a problem, the industry really responded well, in my opinion, getting together with, through the leadership of PTI and ASBE, the American Segmental Bridge Institute, getting owners together with engineers and contractors and the suppliers and the vendors to come up with a holistic approach to addressing the issue, and not just saying, okay, we've got a problem with voids in the tendon, let's tackle that. We stepped back and said, okay, that's one thing we need to look at, but let's take a look at everything to make sure we're not, just putting a Band-Aid on a problem and then finding out we've just pushed it over to another area. So we took a look at everything from, like I mentioned earlier, the materials that we were using, the type of, like, the duct material, the grouting material, certainly, to the design of the systems, where are the vents located. We learned through testing that the way the grout flows over from high point to low point, it rolls over like water, then backs up and creates a cavity at the high point. If you don't come back and burp that air out of there, you leave a void. And when you have a void, you have a potential for the strands to be exposed and potentially corrode and have problems in the future. So we've learned about all these things, so that the details have been updated. The earlier systems had grout caps that essentially fit on the face of the anchor head, the wedge plate, and then it was temporary, and it was taken off once the tendons were grouted, and they would pour back potentially the pockets. But we've also learned now that we want to completely encapsulate the main tensile element, the strand. So the grout caps now completely cover the anchor head, and they're permanent. They don't come off. We built in expectabilities into the anchorages and the grout caps so that we can confirm that there's no voids behind the anchor, through incomplete grouting or bleed water. The grout mixes have been designed now that they really don't have bleed if you stay within the parameters and you mix it per the specifications. We also learned that it was incredibly important to train the crews, to teach them how to, properly install the tendons, properly locate the grout vents, properly mix the grout and inject the grout, what to test for, when to test, what temperatures we need to maintain, how to condition the grout material before you grout. Even looking at the equipment that we use for grouting, back in the 80s and early 90s, we used these big paddle mixers that moved fairly slow. And when we switched to the more complex thixotropic grouts, those paddle mixers did not put enough energy into the grout to wet all the particles. So we had to shift to these colloidal mixers that really put a lot of energy into the grout and get all the particles wet, so we can eliminate the potential for bleed and segregation. And we've even included training for the inspectors. We've gone through now and trained our installers, and we're finding out some of the inspectors were not up to speed with the latest technology and what we've learned, and we're asking people to flush tendons before we grouted. Well, we know that now that is a bad idea. You shouldn't be flushing tendons. If you have a problem during the grouting operation, you need to stop and document it and then come back and complete the grouting operation once the issue's been resolved. Just flushing a partially grouted tendon just creates a big Swiss cheese of grout inside the tendon, and it also adds a bunch of water, so the quality of the grout is going to be affected. So we know flushing is a bad idea. So training the inspectors on the proper techniques and methods is important as well. And then establishing a specification. PT&I has developed, two really good documents that provide a lot of instruction to the owner and the engineers on how to install, and the placers on how to install post-tensioning systems. And there's state of the industry, state of the art specifications. One of the things that I think has happened in the past is that an owner would develop a specification, and then it may not get updated for like another 8 to 10 years. So that technology, there's a lot of learning that goes on in that period of time, and so the spec is not kept up with the technology. So you end up being on a job where a spec is forcing you to do things that we know is not right, so we have to deal with that. And so by adopting PTI, which a number of states are already beginning to do, they're able to make sure that they're keeping up with the latest technology and what we've learned, whether it's using cement grouts or using flexible fillers or potentially using other materials like epoxy strand, external tendons, electrically isolated tendons. There's a lot of new technology that's coming forward that PTI and ASB are going to be working to make sure that these specifications stay up to date. And so the owners are getting the most current specs out there, so that the structures we're building now, like you said, Tim, early on, are not what our grandparents were building back in the 60s and 70s. These structures are, and to be fair, those structures have performed outstandingly. There are a couple of projects that have had issues, and there's a couple of pictures that have floated around, and I see it all the time. And it's like, because you see this picture all the time, you think it must be happening everywhere, but it's the same picture. They keep showing it to everybody. It's not like there's 50 projects out there that have this same problem. It's just one or two projects that had a problem, and you see the picture over and over again, and there's no context provided to it. So I think it's important to get the message out, and I really am excited about PTI taking on this podcast to help spread the news that post-tension concrete bridges are durable and they're going to be around for a long time.
Right.
And as we become more aware of sustainability and the things that we want to make sure that our grandkids and our great grandkids have the same luxuries that we do, we need to start taking be good stewards of our environment.
Well, you definitely touched on some really important things there. And one of the themes I heard in what you're telling us and talking about is one of the key things I love the most about what PTI's approach is we're not standing still. We're not resting on our laurels. We're sitting here, and there's kind of a 3 points of a triangle I kind of refer to myself a lot of times about the specifications, the materials themselves, and the workmanship. And as you touched on as well, we not only have spent a lot of time enhancing the specifications, which need to be employed by the owners and designers at the front end to put forward the right requirements, but then making sure those requirements are followed through on in terms of materials. One of the things that's great about what PTI has been doing recently is our CRT 70 committee and our certification program that we've launched for post-tensioning systems, the qualifications, testing, approvals, they get certified. So these type of systems used in these bridges are going to be going through a PTI certification program, again, affording owners another example of making sure on the QA/QC basis that something has been vetted and it's of the correct quality and meets the specs. And then also with our certification programs, which you touched on, which has to do with field personnel, inspectors. You can have all the best materials in the world, and then if it's not built right, that's going to fall through. And if you build it right, but you don't have the great materials, then it also doesn't work. So we've worked really strongly on all 3 points of that triangle to make sure that that's where the industry is moving, and that's where we've improved all the aspects that all fit together like a puzzle. Because without it, you can't just solve one of the 3 challenges. And I've been very pleased to see what not only the M50 committee that you lead has been doing, but all of our other committees and the Institute in general to really, and ASBE, like you've mentioned, American Segmental Bridge Institute, PCI as well, other elements of the industry have been making major strides, and it's ongoing. It's never ending. So
it's we have there was an article published in Aspire a couple of years ago that looked back at bridges that had been inspected and found a certain percentage of voids and tendons and a certain percentage of corrosion in strands is maybe a small percentage for bridges that were done in the 70s and 80s, and then if you look going forward from 2000 to now, it is essentially nothing. There's been no in all the inspections that have been done, they've found no voids and no corrosion of these tendons when things have been done correctly, and it's night and day. So when people hear about this myth that PT bridges have this inherent issue with durability and corrosion, it's just not accurate. It's just not true.
Right. Absolutely. Well, that's great. Well, I think I'll probably wrap us up here. We've touched on some really important topics. Like I said, the major advantages, we could probably go all day talking about those. And then really the key part of busting that myth we just mentioned, I think it's really important. And I do want to mention to people as well that we definitely have lots of resources at PTI with our webinars that we do every month, and all of our publications and our technical sessions that we provide at our conventions. We have a bevy of resources that can expand upon this conversation and really take us into even more details about how post-tension concrete bridges work, what we're doing, how they're designed and built, and all those good things. And so I just want to thank you very much, Bob, for joining us today on this first episode podcast, and I greatly appreciate your contributions to PTI and the industry and your involvement in this discussion.
Thank you. I would like to add one more thing, if I could, that
Sure.
The committees, M50, M55, the other ones, these aren't good old boy clubs. We encourage anybody that wants to get involved, please reach out and get involved, because the more people we have involved, the better things are going to be, the more ideas that get put out there. So if you have any interest in getting involved, I strongly urge you to reach out, and either myself or Tim or PTI, and we would get you on a committee to help us keep this going.
Perfect. Excellent point. All right. Great, Bob. Thank you very much.
You bet.
Thank you for joining us today on Strength in Concrete, brought to you by the Post-Tensioning Institute. We hope today's discussion provided you with valuable perspectives on the advancements and opportunities shaping our field. If you would like to deepen your knowledge or explore additional resources, we invite you to visit our website at www.post-tensioning.org. If you enjoyed this episode, be sure to subscribe to Strength in Concrete on your favorite podcast platform and enable notifications so you never miss an update. Until next time, this is Strength in Concrete, your trusted source for post-tensioning expertise. We look forward to connecting with you next time.